So it says hydrofluoric acid solutions cannot be stored in glass containers because hydrofluoric acid reacts readily with silicon dioxide in glass to produce hexafluorosilicic acid and water. So it says 40.0 grams. What am I doing here? I got to flip my Chromebook around. Otherwise, I'll just pick up a piece of paper and start doing the work on that, and you won't have any clue what in the world I am doing. All right, so it says, what is the limiting reagent? Well, obviously, to get the limiting reagent, we have to write the balanced chemical equation first. We are taking hydrofluoric acid plus silicon dioxide to produce some weird acid here. All right, so we're going to balance this monster. So then I have, plus water. I was like, wait a second, oxygen's not in there. Plus water, there we go. Now, so yeah, I'm going to skip hydrogen because I have it in two places over here, but I got 6 fluorine. I'm going to have a 6 here. And then I got 2 oxygen over here, so I'm going to have a 2 here. 1 silicon, that's fine. Now I have a total of 6 hydrogen here. I have 2 here, and I have 4 here. Let's see, 4 plus 2 is 6. Yep. I have 6 fluorine here. And I have 6 fluorine over here. So fluorine is good, hydrogen is good. 1 silicon, 1 silicon. I have 2 oxygens and 2 oxygens. So what do you know? That wasn't that bad to balance it out. Now the question is, here's my yield. When I react this much grams silicon dioxide, that 90 grams of hydrofluoric acid, I need to find my limiting reagent because obviously this is going to go into percent yield. I have my actual yield, but I need to find my theoretical yield. To find my theoretical yield, I know I have to find my limiting reagent to say, in theory, how much will form. So I'm going to start off here. First of all, we'll switch to brown. Start off with 40.0 grams of silicon dioxide. And I'm going to say when I have 40 grams of silicon dioxide, how many grams of hydrofluoric acid will I react if I use all my silicon dioxide? So 1 mole of silicon dioxide, I've already looked it up before, is 60.08 grams of silicon dioxide. And I know that for every 1 mole of silicon dioxide, I will use up 6 moles of hydrofluoric acid. And I know that 1 mole of hydrofluoric acid weighs 0.006 grams of hydrofluoric acid. So, let's see, get out my trusty rusty calculator here. I got 40.0 divided by 60.08 equals, multiply that by 6, multiply that by 20.006 equals, I will use 79.92 grams of hydrofluoric acid when I use 40 grams of silicon dioxide. So I don't have close to 80 grams of fluoric acid. I only have 40 grams of fluoric acid, which means that I will run out of hydrofluoric acid before I will use up all my silicon dioxide. So my limiting reagent, forgot my I in there. My limiting reagent, obviously, is going to be, drumroll please, hydrofluoric acid. Yay for hydrofluoric acid. What do you think the next question is going to be? What is the mass of the excess reagent? Oh my word. So the excess reagent is this. I want to know the mass of it. Well, okay, Selena and Josh and Porter. Well, really, the excess reagent is going to be 40 grams. That's what you start off with. That's how much there is, right? That's not what it's really asking you. It's asking you, okay, so don't argue with me, Josh. Yes, I get it. It doesn't say, when the reaction is over. But that's actually what we want to find out. When the reaction is over, how much excess reagent do you have left? So what we're going to do is we're going to start with 40.0 grams of hydrofluoric acid. And we're going to see how many grams of silicon dioxide gets used up. And then we can figure out how much is left over. So then 1 mole of hydrofluoric acid is 20.006 grams of hydrofluoric acid. And I know for every 6 moles of hydrofluoric acid, I use up 1 mole of silicon dioxide. I'm just going to peek back and make sure I got that right. Yes, 6 moles of hydrofluoric acid, 1 mole of silicon dioxide. And then 1 mole of silicon dioxide weighs 60.08 grams of silicon dioxide. So now I can go through, and I can say grams of hydrofluoric acid cancel out, moles of hydrofluoric acid cancel out, moles of silicon dioxide cancel out. So it should be set up right. So I'm going to say 40 divided by 20.006 divided by 6 multiplied by 60.08 equals 20.02. But this is 3 significant figures, 20.0 grams of silicon dioxide. So that means I only use 20 grams of silicon dioxide. I have 40 grams of silicon dioxide. So I have 20.0 grams of silicon dioxide remain, and that is after I've completed the reaction. I'll have that much as my excess reagent. Okay, now it's going to ask me, what is the theoretical yield of, hexafluorosilicylic acid? All right, so my limiting reagent is, what was my limiting reagent? Hydrofluoric acid, right? Yep. My limiting reagent is hydrofluoric acid, so I got 40.0 grams hydrofluoric acid, and 1 mole of hydrofluoric acid is what am I putting that? 1 mole of hydrofluoric acid is 20.006 grams of HF. And I know for 6 moles of hydrofluoric acid, I produce, we'll look back here, for 6 moles of hydrofluoric acid, I will produce 1 mole of hexafluorosilicylic acid. Up here on this one, produce 1 mole of H2SiF6. And I know that 1 mole of H2SiF6 weighs 144.091 grams H2SiF6. Make sure I have it set up correctly. My grams of hydrofluoric acid cancel out, moles of hydrofluoric acid cancel out, moles of hexafluorosilicylic acid cancel out. Now I'm left in grams of that acid. So 40 divided by 20.006 equals this, divided by 6 equals that, multiplied by 144.091. I get 48.01. 3 significant figures is 48.0 grams of H2SiF6. Okay, so my theoretical yield is 48 grams. In theory, that's how much I should get. Obviously, what is my percent yield? 48 grams is my theoretical yield, and my actual yield is 45.8 grams. So my percent yield is going to be 45.8 divided by 48 is equal to 95.4%. 95.4% yield. That is my percent yield on that.